Alright, so on this slide we're going to graph tangent just one more time, and then we're going to identify all of the features of this graph. It's going to be slightly different than sine and cosine, so we definitely want to go through this and make sure we understand each component of the graph. So let's first start with graphing this. Again, I'm going to start with my asymptotes. So we know we have asymptotes at negative pi over 2, and we have asymptotes at positive pi over 2. And we know that at pi over 4, at the pi over 4 we get positive 1, and negative pi over 4 we get negative 1, and then at 0 we get 0. And we know the way this shape is going to look. We know that it's going to curve towards the right and get closer to the asymptote but never touch it, and same thing as it goes to the left. It's going to curve to the left and get closer to the asymptote but never touch it. Alright, so there's our basic shape. Let's go ahead and describe the domain, the range, and amplitude. So the domain, okay, the domain is what are the possible x values of this function, right? What are the x values? Now, if we're looking at just one period, right, this is just one period. So we should definitely know that from here to here, this is all one period. It's one cycle of the graph. You may also notice that this length is from negative pi over 2 to positive pi over 2. That's only a distance of pi. So the period for a tangent is going to be smaller than it is for sine and cosine. All right, so going back to the domain, if we're looking at just one period of this, we're going to see that the graph, the x values, are only between negative pi over 2 and positive pi over 2. All right, if we were to write that in interval notation, it would be in between negative pi over 2 and positive pi over 2. All right, so we were using parentheses because it cannot equal it. All right, same thing in the inequalities, right? We don't put equal signs there because it can never be equal, never touch that line. All right, let's look at the range. So remember, the range of the possible y values. So if you're looking at range, all right, what are all the possible y values? It's going up forever and it's going down forever. So your range is just going to be all real numbers. We're going to have all real numbers. If we write that in interval notation, the range is from negative infinity to infinity. As you get closer to pi over 2, the values are going to get bigger and bigger and bigger because remember your tangent is y, tangent's y over x, right? So as you get closer to pi over 2 on the unit circle, the x values get really small. So that's why your y value gets so big, because the x values get really small as they approach pi over 2. So a small number, if you divide by a small number, is going to lead you to a really big number. All right, let's look at the amplitude now. So with the sine and cosine, the amplitude was just the distance to the highest point. But for tangent, that's not going to be the case. The amplitude is going to be the distance now to the point at pi over 4. So this is now your amplitude, this height. In this case, my value is 1, so that's why my amplitude is going to be 1, right? It's that distance. Same thing from negative pi over 4 to that point. That is going to be your amplitude. So if we were to, we're not going to do this in this class, but next year, if you guys take pre-calc or trig, if you were to put a 2 in front of this, then this value would become twice as tall, right? Become twice as tall. So now your graph would look kind of like that, be twice as, it'd be skinnier, right? That's what the A value does, right? It's a vertical stretch, makes it look skinny. Okay, so that's that. So our amplitude in this case is going to be the value 1, right? We say A equals 1, and we always say positive, right? It's always the absolute value of 1. It's always positive. Okay, no matter what, because it's distance, right? It's calculating the distance from the x-axis to that point. All right, so what's the period? So we've already talked about the period, right? It goes from negative pi over 2 to pi over 2, which tells me that the period has only a distance of pi, right? Which is half of what sine and cosine were, right? Sine and cosine, they have to go all the way around the unit circle in order to go through one complete cycle. Tangent only needs to go halfway, right? That's one period for tangent. You go through all the values of tangent in just pi, and then you would go through another period as you continue, right? There are infinitely many periods here, right? So we only have one period shown, but this will continue. This will continue. There's another period right here, right? There's another tangent and another asymptote right here, and same thing on the other side. There's another period of tangent, right? And it just keeps going. But we're only going to focus on just one period. But I want you to know that there are more. Hope we don't want to clear the page. Okay. So, what are the x-intercepts? X-intercepts for this one are really nice. We just have our 0 value, right? We have 0 and 0. Perfect. Our y-intercept, same thing. Intervals of increase. So this is going to be whether the tangent is positive or negative is going to determine whether it's increasing or decreasing. So you're always going to have one. This graph is going to be increasing the entire way, right? If we look to the right, it's increasing. It's going up as we go to the right the entire time. Looks like it kind of flattens out here, maybe for like a second, but it's going to continue to increase. Okay, so we're going to say, so for this graph, it is increasing on the entire interval, right? So from negative pi over 2 to pi over 2. And then decrease, there's none, right? Unless this was negative. Again, we're not going to go through this. Whoops, let me erase this too. We're not going to go through this in this lesson, but just so you guys know, if this was a negative value, then remember that's a vertical reflection. It's going to flip the graph, so the negative version of tangent would look like that. So then you would have the entire thing decreasing, and there'd be no increase. All right, let's go ahead and move on to the next graph. All right, so for this slide, I wanted to look at the cotangent. So we're going to approach this in the exact same way we approach tangent. Now that we're a little bit more familiar with this, we're going to go through it a little bit faster. So first thing we want to go over is cotangent. Remember, cotangent is equal to the x value divided by the y value. So let's start at each of our angles, right? Let's start off at 0, and let's go ahead and calculate that. We know our x value is 1 divided by 0. We get undefined right off the bat. All right, so right at 0, we've got our undefined value. So we're going to go ahead and at 0, we're going to put our asymptote. We're going to put our asymptote right at 0. Okay, so done there. Let's go ahead and look at the next one. So the next value we're going to look at is pi over 6, right? So at pi over 6, we know that we're going to get the x value, radical 3 over 2. All right, let me zoom in a little bit. Radical 3 over 2 divided by 1/2. We know the 1/2s are going to cancel, so we end up with just radical 3, which we know from earlier is 1.73. So at pi over 6, so here's my pi over 6, and we get about 1.73. So remember, that's somewhere between 1.5 and 2. Then we go to our next angle, which is going to be pi over 4. Do that in a different color, pi over 4, which both of the values are the same, right? They're both radical 2 over 2. So we know that automatically that's going to give us 1. So at pi over 4, we know we're going to get a value of 1. All right, then let's go to our next angle, which is pi over 3. So pi over 3, we know is going to be the x value, 1/2, divided by the y value, which is radical 3 over 2, which we know is going to give me 1 over radical 3, which equals to 0.57. So we know that at pi over the angle pi over 3, we get about 0.57. So here's 0.5, a little bit higher than 0.5, is somewhere around here. Okay, so now we go to pi over 2. All right, so at pi over 2, we're going to get this guy right here. So my x value is going to be 0. Right, my x value is 0, my y value is 1, so that's just equal to 0. So at pi over 2, we've just got a value of 0. Then at our next angle here, I'm going to keep on going. There's no other asymptote, so let's keep going. Then we have our x value divided by our y value here. So we have our negative 1/2 divided by radical 3 over 2. We know the 2's are going to cancel, end up with negative 1 over radical 3. We know that one is going to be our negative 0.57. So this is going to be my, this is going to be 2 pi over 3. And at 2 pi over 3, it's about 0.57. Let me actually move this a little bit. That's going to go there. Negative 0.57, so it's right about there. We can, hopefully you guys can start to see the pattern by now. At 3 pi over 4, we know we're going to have negative 1, right? They're both the exact same value, so there's negative 1. Then we're going to have on the next one, then we're going to get, let's see, what's our x value here is negative radical 3 over 2 divided by 1/2. 2's are going to cancel out, and we get negative radical 3. So which we know is about 1.73, negative 1.73, right? So at our 5 pi over 6, we've got negative 1.73, so we know it's in between 1.5 and 2, so it's got to be somewhere around here. All right, and we're out to the last angle, which is going to be pi. Right, so at pi, my x value, right, my x value is negative 1, and then my y value is 0, and look at that, we get another undefined. So let's go ahead and let's draw out our undefined value here at pi. And let's go ahead and combine all of our let's connect all of our dots here, right? So we're going to start off at 0. Notice what happens as I go to the right. As I go to the right, it's kind of increasing, and as I go to the left, it's increasing. As I go to the right, it's going to be kind of decreasing. And remember, it's going to get closer and closer to the asymptotes, but it's never ever going to touch it, right? That's just the nature of it. All right, so now that we've done all of that, now that we know the shape of this graph, we only need to focus on 5 main points. We need to focus on 0, because at 0, that's going to give us our undefined value. At pi over 4, we know we get positive 1. At pi over 2, we know we're going to get 0. At 3 pi over 4, I know I'm going to get negative 1. And then at pi, I know I'm going to get undefined. Yeah, we need to write the whole thing. We know we're going to get undefined. So if we just memorize just these points, then we can just, and we already know the shape of the graph, that should be enough for us to graph it. So let's get some more practice on the next slide.